Okay guys, welcome back. I'm glad I stopped where I did with this example C. Okay, made a mistake, you guys probably caught it, but here I don't know why I'm saying 1 plus 1 is 0. They don't cancel out, right? Actually what should happen is there should be a plus 2 over here, and I think everything else is right. But basically this equation becomes a disaster, right? It still works out to be messy. I think what we wanted in the original is we meant to put this part as a negative 2 sine theta so that you could substitute the sine theta as square root 1 minus cosine squared, and then it would work out clean. So I want you to see this, what to do, but I'm actually going to just say forget about this equation, okay? Because it's more the idea of making this Pythagorean substitution, letting cosine theta be this. And I know you guys can do the algebra, but I don't want you doing it for this problem. Okay, so I'm going to erase all this and get on to the next couple examples. So if you caught that while I was making video 1, then well done. And just a lesson 2, go with your intuition, right? A lot of times your intuition, well, you guys think we're pretty tough on you. And I guess we are sometimes, but we did not want you doing something like this. Okay, that is a disaster. All right, let's get rid of this, and let's go back to my pen. Let's get blue here. Okay. So this example D, right? So now we have a different kind of substitution we're going to make. Cosine x, that's okay. Cosine, that's okay. We don't like this argument. So we're going to have to deal with rewriting this right side. So let's write this first as cosine 3x cosine pi plus sine 3x sine pi. And that is the cosine A minus B formula, right? This is our A, so we have cosine A, cosine B, right? Don't get confused, that's a minus, so that makes that a plus, but this value is still pi. And then we have sine A, sine B. All right. If we work with that, well, sine pi, this is going to be 0, so this is all going to 0 out. And cosine pi is really -1. Okay, so this kind of nasty thing turns into negative cosine 3x. All right. So we still have a problem because we have cosine x equals negative cosine 3x. We want the arguments to be the same. So I'm going to rewrite this, right? And let's do that, I guess. Hopefully we can have some room here. So we've got cosine x equals negative cosine. I'm going to write 3x as 2x plus x, which is negative. And then let's do cosine of a plus b. So that's cos 2x cos x minus sine 2x sine x. All right, cool. And it fit. Sine 2x, that's actually 2 sine x cosine x. And so I'm going to rewrite that so I can take this cosine x out. Okay. So we'll get cosine x is equal to negative, in parentheses, cos 2x cos x minus 2 sine x cos x sine x. All right? So this sine 2x right here, I'm writing as 2 sine x cosine x. And so now that cosine x can come out. So let's try and fit that here. So this is cosine x equals negative, cos x is out, and then I've got cos 2x minus 2, and that's going to be sine squared x. All right. We've got cosine x on both sides. So I'm going to divide by cosine x, but we should realize right here, if cosine x is equal to 0, that's a solution. Okay, so I'm going to divide But I'm also gonna kind of put, let's do it maybe another color here. Let's do like black. We should know that cosine x equals 0, that's a solution. Okay. But if I divide both sides by cosine x, and I'm gonna move the negative over, so that means that -1 is equal to, now I'm gonna rewrite cosine 2x. You know what? I'll do that in the next step because maybe I'm doing too much here. So this is equal to cos 2x minus 2 sine squared x. So that means that -1 is equal to cosine 2x is 1 minus 2 sine squared. Yeah, so that's 1 minus 2 sine squared x minus 2 sine squared x. So let's see if I can get my addition with ones right. If I take 1, move it over, this is going to be -2, right? So that means that -2 is equal to -4 sine squared x. So 1/2 is equal to sine squared x. So that means that sine x is equal to plus or minus the square root of 1/2, which is plus or minus the square root of root 2 over 2. Okay, so I need to underline our equations that we need to solve now. So one is this, and one is that this is true. Okay, and these are general solutions. So I'm going to write the answers actually over here. Okay, so if cosine x equals 0, let's do that in black. So that means that x could be pi over 2 plus or minus 2 pi k, or 3 pi over 2 plus or minus 2 pi k. Now when I write that, we can actually combine these, right? These two solutions together are really the same thing as pi over 2 plus or minus pi k. So to write this a little bit cleaner, I'm going to write those two solutions just as this. All right? And for the other one, sine x equals plus or minus root 2 over 2. Well, that, for that, you basically have these 4 possible angles, right? This is pi over 4. This is 3 pi over 4. This is 7 pi over 4. And this is 11 pi over 4. Okay, and if you notice, these vary by pi. Right? Pi over 4 plus pi is, let me get the mouse. Pi over 4 plus pi is 7 pi over 4. 3 pi over 4 plus pi is 11 pi over 4. No, it's not. What's wrong here, Jeff? Well, this is not 7 pi over 4. That's 5 pi over 4. This is not 11 pi over 4. This is 7 pi over 4. So let me write the right thing, and then what I said about adding pi is correct. Sorry about that, guys. So this should be 5 pi over 4. And this is better, and that's 7 pi over 4. Okay, so our second set of answers to this question coming from this are in blue. X equals pi over 4 plus or minus pi k. So again, that's this angle plus pi, so that's these two. The sine of pi over 4 is positive root 2 over 2. The sine of 5 pi over 4 is negative root 2 over 2. Okay, and then the other one will be 3 pi over 4. The sine of that is positive root 2 over 2 plus pi. That's down here. That's the sine of that angle is negative root 2 over 2. X equals, so let's say 3 pi over 4 plus or minus pi. Okay, wow. So these answers, this guy and this guy and this guy, are all the answers to that equation. Okay, I'm going to do one more page of problems here, and then I'll stop this video and make a third one. Let me see. I think maybe I need a calculator for this, maybe not. Okay. So this is still some review, right? More stuff. Find the exact value of tan 75. Well, that isn't a unit circle angle, but hopefully we're thinking that's 30 plus 45. So I could write this as, this is the sine of 30 degrees plus 45 degrees over the cosine of 30 degrees plus 45 degrees. All right. I don't remember the sum identity for tangent, so I'm just going to write it this way. I do remember these. For sine, well, that's sine 30 cosine 45 plus cosine 30 sine 45. And then for cosine, it's cos 30 cos 45 minus sine 30 sine 45. Okay, this is equal to sine 30 is a half, cosine 45 is root 2 over 2, cosine 30 is root 3 over 2, and sine 45 is root 2 over 2. And then if we do that in a little bit of a different order, well, this is root 3 over 2. Hopefully you guys can read my writing. This is root 2 over 2. That's a minus. Sine 30 is a half. And sine 45 is root 2 over 2. So what is this all equal to? Well, that's going to be root 2 over 4 plus root 6 over 4 all over root 6 over 4 minus root 2 over 4. If we want to merge those and get rid of the 4's, we could write this as, and I'm going to leave it like this, root 2 plus root 6 over root 6 minus root 2. Okay? You guys probably are seeing that you could rationalize that, but that's a different skill than just kind of using the identity. So I'm going to leave my answer as that. I think it actually ends up being, if you want to write a different way, let's write it in black. I think it'll end up being 2 plus root 3. Okay? Whoops. Let's just, I don't like this, so I'll say that. I'll put it in parentheses. Okay? Either of those work. Find the exact value of this. Well, this looks like, if we're thinking about our identities, we've got sine, cosine, cosine, sine. So this is not a cosine in the ID, right? This is a sine ID. This is a plus, so it's the sum of two things, and it's going to be these two added, right? So this really is the same thing as saying the sine of 5 pi over 12 plus pi over 12, which is the sine of 6 pi over 12, which is the sine of pi over 2. And that is 1. Okay. Wow, it's nice to have a easy one after a while. So that is our answer to this mess. Last one. Let's see. Show that sine 3 pi over 2 minus theta is equal to negative cosine theta. So, okay. Hopefully not too bad. This, we got to use an ID. This is sine of a difference. So this is equal to sine 3 pi over 2 times cosine theta minus, again it's a minus because this is a minus cosine 3 pi over 2 sine theta. Okay, sine 3 pi over 2, well that's straight down, so that's going to be negative 1. The cosine 3 pi over 2, that's straight down, so that's 0, right? So this is really equal to negative 1 times cosine theta minus 0 times sine theta, which is negative cosine theta. All right, so we got negative cosine theta, which is what we wanted, starting from this. Okay, last one, right? Cosine of arctan 1 plus arc cosine x as an algebraic expression. Wow. All right. So first thing is to remember that these notations, those are really the same exact thing as using this other notation for inverse trig. Okay? So what I'm going to do is use cosine a plus b, right? So this is equal to cosine of arctan 1 cosine arc cosine x minus, again, because this is a plus, I'm going to subtract sine arc tan 1 sine x. Okay, so arctan of 1, right? So let's break this down. Arctan of 1, this is saying what angle has a tangent equal to 1. So I'm going to say that's pi over 4. The cosine of pi over 4 is root 2 over 2. All right? So maybe I should do that in 2 steps. Yeah. So this is equal to the cosine of pi over 4 times, now here, the cosine of the arc cosine of x, it's just going to be x, minus the sine of arctan of 1. Arctan of 1, again, it's going to be pi over 4. So I'll write the sine of pi over 4 times sine x. Okay, and then this is going to equal, well, cosine of pi over 4, that's root 2 over 2 times x, minus the sine of pi over 4, well, that's also root 2 over 2 times sine x. And therefore, if we want to clean this up a little bit, oh, and I just realized, guys, sorry, I was a little bit worried about this, because that's not really what we want. We want to get rid of all the trig. So cosine arctan, cosine arc cosine, sine arctan, and I have sine x. I should have arc cosine of x. So if we change that, then we'll get something that's better. So this should be sine of arc cosine x. Okay. And that means this should be the sine of the arc cosine of x. I don't know how I'm going to fit that. Shoot. Let's see. Maybe I can just write it like this. Sine arc cosine of x. So, how do we do this? What is the sine of the arc cosine of x? Well, the sine of the arc of arc, this is what I'll do. I'll do it here. The sine of the arc cosine of x, right? Get a different color here. Right, what this is really asking, whoops. What this is really asking is, what's the sine, right? What's the sine of some angle that has a cosine of x? So the way I could think about that is, I could draw a right triangle, right? If I want my angle theta to have a cosine of x, well, that means the adjacent over the hypotenuse has to be x over 1, okay? So remember, this is saying what angle has a cosine of x? That's the same thing as saying, well, the cosine of the angle is equal to x, okay? This is a right triangle, so to solve for this, I do Pythagorean theorem. I do this side is equal to 1 squared, which is 1 minus x squared, square rooted. Okay, so this side right here by Pythagorean theorem is equal to 1 minus x squared, square rooted. Okay, so then if I take the sine of that, right, for this, If I take the sine of this, well, it's opposite of hypotenuse, so it's square root of 1 minus x squared. Okay, so this whole thing, I know it's a little bit confusing, but that turns into this. 1 minus x squared square rooted all over 1. So I'm going to write that, this over this, down here. And then that'll save me a little bit of space too. So this is square root of 1 minus x squared over 1. And then we know anything over 1 is just itself, so then I can write that a little bit cleaner. This is the square root of 1 minus x squared. Okay, so finally, clean this up a little bit and we can say, well, that's root 2 over 2 times x minus square root 1 minus x squared. And that, ladies and gentlemen, is our answer. Root 2 over 2 times, in parentheses, x minus the square root of 1 minus x squared. Wow. I'm just realizing maybe that's a little bit unclear, that last part. So let me see if I can draw that a little bit better, or write that a little bit better. This should be x minus the square root 1 minus x squared, in parentheses. Okay. I'll stop this video there, and then we'll go through this next set of pages, which looks like it is pages 4 to 8. Yeah, actually 4 to 10. Okay. So